selvom du taber så meget, 4.000 kroner på det. Så hvis der er små penge i forhold til 4 måneder med hotel og det hele, så er det noget, som ikke rigtig fører mig. Så det kan ikke nok. Man kan godt have det lidt bedre, men jeg har det jo sådan, mindst en gang om året, så kommer jeg til at lave sådan til at fuck op for et andet. Det gør jeg ikke, hvor jeg kunne flytte lidt i mig, for eksempel. Det er i stedet for København, så det er jo, den er bare spildt. Det er jo til 4.000, til 3.000, der er meget fjord. Så kan man komme til at tage sig noget, hvor man så pludselig må aflyse det. Men ellers, hvis bare man har en track rate, altså når man kigger sådan, i det lange, lad os sige, når jeg tager de sidste 8 rejser, og så kigger jeg gennemsnitsbetragtning, og det er så fornuftigt, så gør det jo ikke noget, eller andet. Det er kæst. Men hvis de alle sammen er det, hvis de alle sammen er sådan nogle vildt dyre nogen, så er det suspekt, ikke? Hi, you're the technician?
Yeah, we're just testing so it works with the cameras.
Okay. So are we streaming?
Yeah.
Now already? We're live?
I think it's going to be published afterwards, but...
Afterwards? No, it's not streaming, right? No, it's live streaming. Yeah.
Oh, yeah.
But I suppose some guy has to press some button. Maybe we were online.
No, there's 2 camera people behind the...
Okay, that has to be before the streaming.
Yeah. Kit? Funkar det? Yes. They're not ready yet.
So why are you on this slide number 6 or whatever?
Just...
You just pressed whatever, okay.
Yeah. Yes. Är ni redo att köra igång? Okej. Now we're ready.
So we are ready to start, and I would like to welcome you to this session this afternoon about data management from innovations to politics. My name is Gitte Kusk, and I'm head of secretariat at the Danish E-Infrastructure Corporation. It's on? It was on, I think. Okay, should I start over? No, well, the session will take you in a broad perspective on data management, and we will start at looking at some strategic decisions we have made in Denmark on a national level, and then we will have a presentation about an archiving service and a data analyzing service. And we will hope to have a bit of discussion at the end and some questions. But I would like to start with welcome my colleague, René Belsø, who is Head of Development and International Relations at the Danish E-Infrastructure Corporation. And he has been taking care of the secretariat function for a national appointed steering committee on data management, who have just now finalized their report. And yeah, I think René will tell you more about that. So welcome, René.
Yeah, hi, good afternoon. René Belsø. So I'll put up here, I suppose it's this. And Yeah. Is it coming? Yeah, right. Okay, so I'm here to speak about strategy within data management. And I intend to run you through these points here in my 25 minutes. Of course, where the most interesting stuff will be at the end. But I think you need to know the setting and the mandate and why are we at all doing this, who are we, and so on. So I will start by saying what we do in our organization and why we have this task and how we understand this task, what's it all about. And then I'll get into the strategy work and run you through what we have been working with in terms of strategic findings and so on. But before that, we will just set the stage, what are the key issues here, what are the key principles, and what kind of strategic areas are we into. And then we will have a strategy discussion at the end, possibly, if we have time for it. Or we can just take it at the very end. So, Gitte and I, we come from the Danish National Infrastructure Organization. We have a mandate from the Danish Ministry, and we have the task to provide infrastructure for Danish research. And we have a number of strategic goals, of which you will observe that the second last one is specifically about data management. So you can say that we are dealing with data management because that is our job. And the way we deal with it is, of course, that we should be providing data management to our researchers. Alas, there is no infrastructure and data management on a national level in Denmark. So what to do except to start at the strategic level, which of course then we have done. So just to say something about what this is all about. What is data management and what is it that we need to think strategically about? And I think probably for most of you being at an infrastructure conference, you know what this is about. But just to remind you, it's all about managing research data. And research data is basically anything digital, really anything digital. And it can be also at any stage of the research. It can be something very ordered and of high quality, like a scanned Picasso or whatever. It could also be a lot of messy bits and bytes, which you don't really have any way of finding out what it is at the moment, but you're working on it. And data can be anywhere at any stage. And there are various people, various research projects, various papers who write about data in all these different stages. And it's termed the data life cycle. And our focus is every part of this life cycle. So there is none of it that is not relevant. And there are many ways of presenting this. I've taken a few. This number 2 one is the one we like. It was devised by my good colleague, Deepa, who, by the way, is the one running this more than me, actually. She made this one, and our National Data Management Group, they liked this one. But there are others, and I can't really say that they are better or worse. Then there are some that are awfully messy, like the one in the corner. I just took it just to show you that some people have been really thinking about this and put a lot of detail into it. And then this about managing. What is it we have to manage? Well, it's actually all data, but the stuff that we really need to focus on and manage is what we can understand at the top of this big lump of data here. It's the data that we somehow want to reuse or think could be useful to be reused. Either we have it now, we want to reuse it in the future, or it's something that has been produced earlier and we want now to use it. But there is a lot of other data that is not at all ordered and is one big mess. And this lump here, this iceberg, it's growing in a magnitude very fast. And the next picture shows this point here. That actually the amount of data, coming from all kinds of cheap little sensors from all over the world, it's staggering. And most of this data is so much of it that it never has a chance to be used in any meaningful way. But nevertheless, better safe than sorry. We don't know what we will use. We just collect it all if we can afford it on disks of various types. Some research groups, they collect huge amounts of data and use very little of it. Private businesses also collect huge amounts of data. And the capacity to analyze it, I mean, in terms of compute resources and so forth, are very small. So when we speak about managing, we speak about managing this digital data. And why is that important? Well, it's important because it's a research resource. So it somehow constitutes something valuable. Without this data, we wouldn't be able to do our research. So in modern times, more and more research is dependent on some kind of digital data that is produced God knows where. And it would be irresponsible not to take care of anything that has value. So, but of course you could argue that this is the job of the research community itself. If it is important, they will take care of it. If it's not important, they will just lose it. So why bother? Well, because it constitutes something that is so valuable, not just to this research group, and it has been produced through university or taxpayers' money, and if it is lost, it's not just because it's not useful for this research group. It could also be because they were clumsy, they didn't take care of it. It could also be that it's actually not useful for them, but it could be useful for somebody else. And indeed, that's often the case. So it has to be managed for this value proposition reason. It also has to be managed because it's a kind of it's a foundation of the scientific concept in that it's a postulate about something. Science is saying that this is so-and-so because so-and-so. And you base this science on, as we know, theory or inquiry. So to base it on data and then not have this data is just not scientific. So you have to be able to reproduce your data and say, this is my data set, these are my conclusions, and if you want to test it, what is called falsifying verifying or falsifying has to be done continuously. So for this reason also this data has to be collected. We've had a few scandals in Denmark, for example, about researchers which didn't quite do this, and then it turns out that this data they were building their theory on wasn't quite that data, and it turned out that actually they were cheating. Of course, because of this value and because of this importance to science, it means it has to be managed. And it is not reasonable to ask this management from the researchers themselves. They have to participate, maybe they should be bound to do so. They have an own incentive, but only to some limit. Right, so that is the argument for why a national infrastructure gets into the business of making a national data management strategy. It's because it's important to the nation and for research reasons. So what was it we wanted to do? Well, actually, we just wanted to have a strategic understanding of how can we engage in this data management. And what we did was we collected all the interested parties, the librarians, the university people, and so on, with some influence on this issue, and discussed with them in a big group about how to understand this. And they came up with this mission and this vision here. And it's pretty straightforward, but it could actually be understood in many other ways too. It could be much wider, it could be much more narrow, but basically this is like the point of departure. This is how we understand what has to be done. So you can see this mission thing here, it really focuses on the value aspect of this. The data is valuable, and that's why we have to take care of it. And the mission, the vision, how we see the future, that is because we do this, we can then simply make better science. That's what it's about. Okay, so what we did was we did one of these very Nordic, Scandinavian anchoring processes. We didn't just set down a group and ask them for a strategy. No, that just wouldn't work. That doesn't work at all in our part of the world. You have to have the people who have influence over this, who own this in terms of funding, in terms of organizational power, and so on, to stand behind the strategy. Otherwise, it simply won't work. And who are these? Well, they're of course the universities. They're the ones which are dealing with the research. So we had to get all the universities together. And then we had to get all the libraries, because the libraries are also, the national libraries are also very much into this. Even to some extent, they have it in their raison d'être, that they have to take care of the data, mostly on the archiving side, but nevertheless. And then we have a few organizations like our own, which of course have a job to take care of this. So we are also an interested party in this. But of course, our employers, the ones we do this for, are mainly the universities. So we are more like a listening administrative secretariat function, whereas the university people, library people, are the ones who own the strategy. So we get these people together and have a big group, and they come up with some kind of recommendation understanding of this. And it was like a 2, 3, 4 page document, and they send it back to these boards here, our board. And they say, okay, this is all very nice, so we have to ask the university at the rector level. I mean, what do they think about this? Should we engage in this process? Should we make a national strategy? So we sent this proposition to them, and they responded, yes, we think it makes sense. We think we should do something about this. We should indeed make a national strategy. Hence, a new group was formed with appointees from all the Danish universities, from the head of the libraries and so forth. So like a second group, a little like the first, but on a more high level and more formally presented. What? I should speak in the microphone. I see, but it's fixed here. That means I can't move around. I will just stay put. Where did I come from? Yeah, this about bringing this second group on a more high level. So then they were meeting and sitting down and like redoing the whole idea, thinking, okay, what's this about, and where are we going with this, and so forth. And they did this. This group was called the Steering Committee for National Data Management. And they drafted a strategy, and this strategy is now written, and it is in a national consultation, in the real Scandinavian way of doing things. And then we expect that some comments will come, maybe something will be modified, and then this strategy will become the strategy. And then we can say, okay, then what? What does it say? Right, now we get to the essence of this. No, first we have to, before forming the actual strategy, a few kind of baseline principles were decided upon about what is actually the subject matter here. And this is a number of basically reasonable points of departure, of which you could be in agreement or you cannot. But how to say, in Denmark, the main Danish actors, they agreed on this list of main guiding principles. And I'm sure you will agree that they are, by and large, pretty okay. Though each of them could be, of course, discussed, and some of them you might not agree on. I won't go into them. There's a few more here. This is, I think, a little more important. That was that it was also decided that if to make a national strategy on data management, it should focus on these issues. This is what it's about. And as you will note, it's, for example, not just about making data management infrastructure, which is this point number 3. Oh no, it's also about the policy framework. I mean, what are the rules of the game here? What's the law? Is there a law from the ministry about data, like in some countries? Then there is the whole thing about, well, even if you have rules and laws and so on, even if you have infrastructure, but if the researchers have a reasonable degree of autonomy and they don't care about this, they will do as they please anyway. So then you get into the whole story about incentive structures and so forth. Then there is this about competences. I mean, if people don't know about how to handle data, if they're not used to it, I mean, my mother, she has like a terabyte of family pictures, and it's a huge mess. And every so and so often she loses half of it. So of course you have to have some competence in this field. And then there is the governance structure, because this is not a one-shot effort. I mean, getting into the business of data management, it'll be an ongoing process for the foreseeable future. So it needs some kind of governance structure. And then, well, probably you would need some experimentation, some piloting, and so on also. So that's why these. So now we get to what did we then learn from this process? I think we had like 4, maybe 5 national meetings, which led to this strategic findings. And well, the most interesting was, in my words, because it's formulated pretty long, in my words, an interesting finding was that actually the national level in coordinating and making a big change as to data management does not lie on the national level. It actually lies mostly at the local level
That's where the effort is needed. And then at the international. And for a country with 5 million people, maybe that's not so surprising. Because whatever we make at a national level, if we're only 5 million people, that's like some little corner of Berlin would be equivalent to what 2 universities in Berlin would make. So why make it at this level when it could be made at the university level of the 8 Danish universities? And then again, when they're making something, especially if it's infrastructure, why at all make it at the local level? Chances are it'll be something of poor quality, not really ever standing a chance to become a viable infrastructure. So it should be made on an international level. That was an interesting finding. That was rather surprising for somebody whose business it is to work with infrastructure on a national level. Yeah, then there was this about this top-down thing. So researchers, by and large, are very skeptical to national agencies and national level initiatives which enforces things on them. They just don't like this. They usually just want autonomy for the purpose of autonomy, which is maybe not so sympathetic, but actually they have a good point very often, and that is, if this data is important, they will take care of it. We have to assume that the researchers know their business and know their data and know how to take care of their data. I mean, that's their job. So why at all come here as an outsider telling them how to do their job? Good point, good point. The only thing this argument forgets is that sometimes this data is valuable for somebody else other than them, and by far it's been paid for by somebody other than them. So it's not always that they're right there. Then there's this thing about that data is so subject-specific. So like if you bring together a bunch of archaeologists, archaeologists and pictures of skeletons and so and old buildings and so forth. So their challenge within data management is very different than if you go to some nuclear physicists or computational chemists or material science. It's simply a complete different way of handling data. And that is different in terms of administration of this data, quality assurance, as well as infrastructure. Really, that undermines the point of making a national data infrastructure to some extent, because of course there is some degree of how to say, joint needs and common infrastructure demands. But one often tends to forget that. Yeah, what's that? Then there's this thing about that if you do then make an effort to manage this data, either in terms of organizing it or in terms of making an infrastructure, then probably within a certain specific within a specific research area, let's say like bioinformatics, they are part of a global community of bioinformatics science people, and they've already been thinking about this for 20 odd years. So really, for a Danish effort to go in and say we have the solution, when the global bioinformatics people have been working with this with a 20-fold bigger budget and with much more competence, come on, we would be stupid. So we really have to think about that before going into pushing something their way. Okay, then there's this point about, so when we do something at the national level, there's this point that it has to come from the owners. It has to come from the people who are the ones funding the actual research. That means the universities and so forth. It must never be a national infrastructure's homegrown idea. This is tough medicine to swallow if you're in the business of being a national infrastructure provider, that it's just not welcomed that you invent things yourself. It's just not welcomed. But of course, it doesn't mean you're out of business. It means that whatever you do, you have to go and clear it with these people, or you have to take their ideas, not your own idea. And the last thing here is that this, as I said, has come to stay for a long time. So you have to have a kind of long-lasting governance structure for how to deal with this. And, well, some kind of group of some kind. So let's make a parallel to the networking business. Like most of the people here at this conference there have been working with networking infrastructure for the last 20-odd years. They have different policy forums. They have different technical references groups and so on and so on. And this organizational structure has been around for many, many years. So of course, why would you expect different from when it has to do with data management? So, I'm sorry about that this slide is in Danish. I just didn't have time to translate it, and maybe it wasn't worth it. But it's just some organizational drawing, like you've seen so many, which it tries to map the role of this National Forum for Data Management. So some kind of way of organizing this. I won't go into details. It looks pretty complicated, but what's it basically about is that it's a bottom-up process where you get the people together from the various universities. 5 minutes, okay. And you make them work together basically with knowledge exchange. You could say it's a lot of chit-chat, not really leading to anything, but let's start from there. And then with some specific tasks like point at this generalization or that and so on, and then see where it goes. But then give them a steering committee, which refers to the owners, to the university rectors and to the Dike board and so on. And if they don't move anywhere and they don't do anything, well then maybe throw them away and change them out with something else. But let's give them a chance. So the strategy ended up with some specific, like concrete recommendations. And it's basically these different, within these 5 points which I opened my speech with, there are a few recommendations within each of them. And the most important one is, of course, to make this structure, this forum thing, and its governance structure. And then within a few of these other areas, there is something also pretty concrete, like within the infrastructure. Okay, we should make some pilot efforts, we should make a few experiments, we should maybe go with the bioinformatics, the computational chemists, see what we can do for them. But on a pilot basis, I mean, admitting that maybe you do it wrong, you have to throw it away and redo it. Don't make it too big, and don't expect it to be a success. And then make one infrastructure thing which really went through time after time. It was this Dropbox thing. So it seems that this kind of managing researchers' data, this working data, I mean not their databases, is a very important thing, and everybody faces this challenge, and everybody turns to Dropbox or the 25 other, like Google Drive or whatever. And the universities are very unhappy with this, basically because it's out of their control. The data could be lost, the professor could die, and by the way, the NSA knows everything what's going on those drives. So this is a problem, and the group has been asked specifically to address that. Okay, so here's the funding. It's a few million euros here in the beginning we'll spend on this to see where it goes. There's some train the trainers and some different stuff here. The forum takes the most of the funding. Then for the future, for my closing here, it's my last slide, is so what can we expect here? So of course the Achilles scene here is this forum. I mean, is it just a bunch of people getting together and having a few ideas and talking, not doing anything? Could well be, seen it before. Or do they actually have some great ideas? Will they actually manage to convince their managements that this is worth pursuing? Will the owners, in turn, choose to fund it, put more money into it? Will they give them the clout to actually enforce these things? Let's say we make a Nordic Dropbox solution. Then if nobody cares about it and nobody will use it, even though it would be good, it would be terrible. If it wouldn't be good, it would be good that they don't use it. Then there's this thing about that the researchers, I mean, this thing about is it the right approach to just simply take it bottom up and let the researchers be in control and see where it goes, or is that just too little, too late? That's the big question. I mean, do we need to take a grip on this and really enforce something, build some infrastructure, take it somewhere with the risk of going the wrong place, or do we relax, see how it goes with the risk of doing too little, too late? That's the future will show. Thank you. So questions? No, later? Yeah. Okay, there's a question. Yeah? I have to use the microphone for the streaming.
Is it on? Yeah. We're currently working with a project like this within our.
I can't hear you.
We're working on a project like this within our university, gathering the library and the archive and the researchers to make a system for archiving and making available our research data. And the biggest worry for us right now is who's going to pay for the data storage. Because when people actually start using this, what is going to be the model for financing the storage? Especially as you mentioned, biometrical data or genetical data will be huge amounts of data. That's one of my questions. How are you going to finance the storage? And then as what you told about should you regulate this or not? I think definitely you have to regulate the use of metadata, because you can't make the data available for anyone else to use if you don't regulate how people use metadata. If your researchers only put the stuff in Dropbox environment, it won't be available to anyone else unless it's tagged with the correct metadata. So, but to the costs, what's
okay,
your
so
solution?
It was something about funding and regulation. So as for funding, I can't say. We're not there yet in Denmark. I can guess. I can give you a pretty good qualified guess. Would be that in the beginning it's for free until it's been piloted, tested, and then some kind of funding model will be introduced. Maybe a base subsidy, and then with added user payments. I'm pretty sure something like that.
A major drive towards Dropbox is that researchers are really averse to costs. They have huge amounts of data, but they don't want to pay for data storage. That's something that drives them into these kind of...
Yeah, but then you either have to say that they're pretty stupid, or you have to say that they are wise in being cost evasive. So that means that the data they don't want to pay for is maybe not worth saving.
No, I wouldn't say that they're either unwise or not, but at least in Sweden, the way researchers' terms of employment and their career is so connected to their own achievement in this moment, so they can't afford to take the larger perspective.
So that you cannot expect of them to carry costs related to the good of the nation, so to say. Yeah, that's true.
Of course not. Yes. That's why you have to regulate.
Yeah, okay. Sorry for misunderstanding you. Yeah. Okay, how to deal with that? Okay.
Hi, Dan Stell from CSC Finland. So actually, when I was listening to the last commentator, then I've been involved in the data management project that we've had in Finland for a number of years, and we actually do have an infrastructure that has been paid for by government. So we have approximately 5 petabytes of storage, which is fundamentally funded by the Ministry of Education in Finland, and this thing with metadata is really a key issue here. So that's kind of the driving force, and it's also very hard to get actually from the researchers attach meaningful metadata to the data sets that they're actually storing. One thing is also of course to gain the trust from the community. That do you actually want to store your actually really valuable research data until you sort of pressed out the last drops of it in the forms of publications. So this is a very sort of standard comment that we've been getting, but one driving force, and that's and I also need to say that there's no, to me there seems that the only way to sort of fund this is really in government, in some type of government funding. So it's very hard to sort of get individual research groups to sort of.
The problem with government funding is that it might risk keeping you and me occupied with a salary which is not worth paying.
Well, yeah, it's kind of give and take. Have to remember also that individual research groups they actually typically don't have this kind of money, and also one driving force that we've actually discovered in Finland is really long-term storage. Well, actually, I should say long-term preservation, which is really what people are looking for. 50 years and upwards towards 100 years. So, and that's of course a very expensive proposition, and that's of course where things get really interesting, because
that some structure has to decide if it's worth it for this specific data set. So
right.
If it's genetical material,
Yes.
blah blah blah, then you can argue the case. But I mean, otherwise you risk having to pay for storing stuff, which really nobody has any idea about.
Right. So you're talking about the quality of the data sets. Yeah, that's of course a challenge. You know, is this worthwhile storing? That's of course really difficult. In Finland, we've actually done that in this way that the universities have a quota. So they have a quota per university of the 5 petabyte
but anyway,
at the moment.
As long as we're playing around and we're starting up on this, we're speaking small money. But at some point, it just doesn't scale.
Right.
Too expensive.
Long-term preservation is really expensive, though. So that's really a key issue. But yeah, this was kind of my 5 cents on the topic. So love to talk to you.
Okay.
Talk to you guys later on. Right.
Okay.
Finished?
Yeah. Well, very. Very quickly over to our next speaker, and that's Govinder Singh, who has been working at the network department in Uninet for more than 4 years, and he has been working with a data analysis service. And I'll just leave the word to you. Thank you.
Yes, it works if I speak near to it. So I will talk about the data analysis work which we are doing at Uninet. So it's been quite interesting actually at the NordUnet network conference. We have in both days keynotes talking about the big data. So in this talk actually, which is continuing automatically, we'll talk about the work which we are doing at Uninet. So this project actually we started with this year earlier, and this will actually, why we started the project, the reason was that the amount of data is just growing and growing, which we have been hearing now during the conference. And so we needed to look into the different methods how we can actually process and handle such a large data. So if you look at the currently infrastructure for high performance computing, you have the computing resources at one land, and then they are separated with the storage where the researcher can store the large amount of data. So they are totally separate entities. They are not like intertwined. So if, take an example that if a researcher has a 10 terabyte of data, which is not really that big, just a 10 terabyte, and if they want to compute it, they need to transfer this from their storage to the supercomputing facility, which, say if you have a 10 gigabit link, take 2.2 hours, considering that you have the full link capacity reserved for you. And if you are stuck with a 1 gigabit link, you're talking a day just to transfer the data from storage to the computing platform. And you haven't started the computing, you just have transferred to the computing. So the idea is actually, can you kind of combine the storage and the computing in a kind of way that your data is then processed where the data is actually stored. So you actually get away with the performance hit which you get by transferring the data where you need to process it. And so this becomes a kind of a challenging problem because it's not that easy to set up such a large system so they can handle petabytes of data. And for researchers, they are more interested in trying to solve the problem, trying to get the answers what the data contains. I mean, they are not that much interested into setting up the whole infrastructure so that they can process their data. And even if there are some researchers who are really keen on setting it up, they're going to have kind of repeated investment in investing at some certain group, research group A, research group B, so they will be kind of investing in the resources again and again. So it's not that in kind of an efficient use of resources. Another was that it's not just about processing. It becomes, for example, there has been a lot of talk about sharing the results or sharing the data which the research has been used to produce some results on top of that. But if you look into and talk to anybody who actually works in analyzing the data set, getting the data is just only maybe half of the job. It's actually how to transform this data to work with your model and then try to get this to work with the whole pipeline. That's actually quite a big part of the job itself, in addition to writing your own algorithm. So imagine a possibility where actually researchers not only share their data, but also share the whole pipeline, how they have processed it. So that will open up a possibility which is it's kind of really make the kind of revolution in how researchers will collaborate with each other. So imagine a scenario that I, as a researcher, published a paper, and somebody read my paper, and they are interested in to see that yes, their result look interesting, but what if I change this couple of parameters, how they will affect? So they can simply come to this portal and then say, okay, that's the data is shared with this researcher, and they come to the portal and they say, okay, that's how the pipeline is. I changed this couple of parameters to see the results. So then you're talking a collaboration which is not really possible at right now. So regarding that, So how are you actually going to process this with and how you handle this such a challenge? It's simply like brain is quite a good example how it does the things at such a complex scale. Means it has divided the parts in the brain to handle like vision, audio, and it gives the information there where they needed and then process it and it transfer up the results from this part. So the main idea is actually you divide the things and then you handle them. So for that, so to do anything with the data, we need a kind of resources. So we need storage resources where you can store the data. We need the compute resources where you can compute. And you need some kind of resource manager which can manage all these resources. So these are the kind of few basic principles we looked into, kind of what kind of storage system we need if we're going to handle such challenges. So we need a kind of storage system which can scale out, because it's a certain amount of disk you can put in one system. So we need a system where you can actually kind of build the system on rack-by-rack basis. And similarly, we need a system actually that which supports the data locality principle in the storage. What I mean by the data locality is that it gives the information to the processing framework that where this part of the data is located, so that my code or my algorithm, which I'm going to perform this on this data, should be sent to that specific machine where the data is, so that you don't actually transport the data to the computation. And it should avoid a kind of a centralized architecture so that it doesn't have a contention in the performance. And preferably, and it's better if we can build this system on a commodity hardware, because that becomes cost effective. Otherwise, you have to buy an expensive SAN-based and systems which becomes really expensive. So these are some kind of some of the components which we looked in. There are a few animals in the zoo actually, because in big data they are very happy and interested in the naming the names on the animals. So I will talk about mainly the bottom part here with a file system, which are the distributed file system in this part. And this is a Apache Mesos project, which actually act as a resource manager. So consider this as a kind of a distributed nodes here, multiple of these nodes, which providing the distributed storage, and then providing the resources to compute them. And Mesos is managing all these resources. And Spark is actually one of the distributed processing frameworks, which provides a kind of a paradigm where you can compute the computing process where the data is, with the help of Mesos and the underlying file system. And these are on top of the different components which Spark supports. So if you are interested in more detail about any of the components, you can talk to me later on, because in this talk I will go mainly about the brief into them, because they in themselves, each of them are quite complex to talk about in detail. So first we go into the storage. As I mentioned earlier, so we actually set up a defined criteria, on which we try to select the different system which we can use to store the data. So one of them was actually we looked into called Hadoop file, distributed file system. So what it does actually is just simply, it demands you have like a multiple distributed servers. Each has some certain amount of cheap SATA disks. So what it does actually then, and that there is one master node which they call name node. So name node actually knows where the data is. So as a client, for example, I want to store a file. My file is 1 gigabyte. So what it does actually, it goes to the name node and it say, this is my file, I want to store it. And then this name node will decide on which servers I have the disk capacities. And then based on that, it will say, go to these servers and store your files. So when I'm going to read it, and then I go again to the name node, because the name node knows on which blocks or which servers the blocks are located. So it has this kind of a centralized architecture that you go to the name node, ask for the storage as well as retrieval. But it scales quite well. So for example, the Yahoo, Twitter, Google guys, they store petabytes of information in such kind of systems. So scalability is not a big problem. And another one which we look is called Ceph. It's based on the similar principle that you divide the data into small chunks and store it. But what's the difference between Ceph and HDFS is that in Ceph, there is no centralized control. It uses some hashing algorithm called Crush, which is controlled, replicated, and scalable hashing. It's a hashing algorithm to find out that you give it a file name, it takes the file name, and based on that and some other certain parameters, trying to find out which server I should go to store this file. And because the whole kind of cluster understands and uses the same hashing function, so given the same input, every part of the system knows where the data is. So there is no center intelligence in this case. So it's avoid this kind of a single point of failure scenario. So that makes it quite attractive. And it's again supports the data locality as well, and scalability is not a problem because there is no single point of failure. And it added advantage of this on top of that, the HDFS is more POSIX compliant file system, and it also supports the object storage like an S3 and things like that. And there is another one which we looked is called Gluster. It's to some extent is similar to Ceph because it also uses the hashing algorithm to find the location where the data should be go. But it's, there are fundamental differences on the architecture level at the bottom layer in the GlusterFS. So from user's perspective, there are not that much difference, but fundamentally in the architecture, there are few differences. So after looking at these three file systems, we start to say, okay, then we should run some tests to check the performance and the functionality. So we start to run this tool, use this tool called Flexible Input Output, FIO, to check the performance. But then when we start to run this performance, it turns out that the HDFS is not a POSIX system. So we couldn't run the file system test. So then we run the test on Ceph and GlusterFS. And this is a kind of shows that results from a different test. For example, this is when we're trying to read the data in a random fashion. This is random write. This is random write with the sync enabled that each operation should flush the data to the disk, not just keep it in the RAM to some extent in the buffers. This is sequential read, sequential write, and sequential write with the sync. So in this, you can see that actually especially in the sequential read part, it's quite high spike. It's because it could have been more, but the whole nodes in the cluster had the 1 gig link. So here actually my network link is saturated. Whereas in the writing part, you can see in the random, especially in the random read or random write part, the cluster is performing better than Ceph. So we thought, okay, then the 4K is quite a small block size, so we reduce a bit more. So we increase the 64K byte. So still in the random or sequential read, the network is peaking out. But in the sequential write, the Ceph is much better than the Gluster, but in random, still Gluster is better, which is also one of the requirements if you're looking at the file system. So we said, okay, let's go with more in the block size. We increased to 4 megabit block size. And then Ceph has much better performance, at least has improved performance than a Gluster. So based on that, okay, then we thought, okay, let's do some more real tests. So what we did actually, then we copy a Linux source code tree and try to paste it there on mounted file systems. And it turns out that the HDFS performance was really bad because in the Linux source code, you have very small files. So after like 40 minutes, I have to cancel the test. It didn't get finished. On the Ceph, it took almost 5 minutes, less than 6 minutes, and Gluster was 10 minutes. So based on that, we said, okay, now we should go and test the data locality performance test with a kind of a Hadoop or other processing frameworks. So based on that, then we decided to look into mainly the HDFS and Ceph because of the performance and its characteristics of improved performance with the larger block size. Because when you're talking about the files of few terabytes, you're going to have a block size of 64M or 120 megabytes or even bigger. So based on that, we did another Hadoop-based test. Actually, this is about, for example, this is for reading about 200 gigabyte of data in a distributed fashion. This is 200 gigabyte of writing the data. This is, for this test is, for example, sorting the 200 gigabyte on a cluster. And here is the performance based on Ceph and HDFS. And HDFS seems to be better because it takes less time. So we thought let's increase the size, which is tends to be mostly in Hadoop clusters, which is 128 megabyte. In this case, the Ceph performance has gotten worse, whereas the HDFS is getting better. So if you look at the result, for example, in this case, from 1100 seconds to 980 seconds, whereas in earlier case here, HDFS took only 924, and when I increase the size, it takes less time. So it was inverse relationship between the Ceph and HDFS. So that was a bit interesting, actually. And on top of that, the Ceph was a bit new system. Because we done this test approximately 6 months before. Things are now moving in this community quite fast. So at that time, the Ceph wasn't that much developed. So these were the kind of lessons which we learned from this testing. So HDFS performance was with smaller files was no good, but for this kind of project, we wasn't that much interested in the smaller files. The project was more interested into looking into larger files. So it's and it's not HDFS is not a POSIX compliant either, and it has this kind of a centralized architecture which is not really ideal when you're talking about scalable and reliable systems. So, but it does has a kind of an host standby. So we have seen some now and then that actually the standby takeover one of the because we have in our infrastructure 2 name nodes, and one of the time actually there was some problem with the disk on one of the server, and another system just automatically take over. So it was okay, and from that point of view. And GlusterFS performance with larger block was no go. And at least we haven't observed it, but actually in the community, in the mailing list, people have been complaining that GlusterFS has a problem with the network plane split. What it means actually, for example, that you have 2 racks of file servers, and they are connected with this kind of router or a switch. And they're storing the files because you have some files with the copies on this rack and copies on this rack, and suddenly like your switch which is connecting these racks is gone down. And now your client comes and is trying to store the data. It doesn't know actually where it's going to be based on the hashing algorithms, and sometimes they end up actually kind of in a conflict between your data. And a GlusterFS doesn't have a good solution how it's going to handle this conflict. So that was quite a problem if we're looking into providing this as a service to the customer. So that's a very simply no-go for GlusterFS. And Ceph is new and is evolving quite at very rapid pace. And its architecture is really interesting because of no single point and very high scalable and functionality like S3. And another functionality which was quite interesting, especially when you're talking in high performance computing systems, is that the dynamic subtree partitioning. What it means is that consider a scenario that one researcher has you locate one directory to one researcher, and this researcher has millions of small files under this directory. And now he's trying to process these files which he has under this directory, and then when he's trying to access it, he's going to read this information about where the data is from the metadata servers, right? So if you have one or couple of few metadata server handling your whole namespace, this researcher is going to kind of bombard with its own request, and will going to kind of drop down the performance of the whole system. But the Ceph does actually kind of keep tracks of how many reference has been accessed to this specific file or specific directory. And if it sees that it has reached some certain threshold which is configurable, it actually spin up another metadata server to handle that part of subtree of the metadata of the namespace. So now this specific researcher's request will go only to this additional metadata server which I just newly created. So it will not hurt the performance of whole cluster. So that was really interesting also. And in our test, we see that the Ceph had that time some kind of long tail latency. Means what I mean, like for 90% of the request was under few milliseconds. But when the rest of the 10% has some kind of a response time of few tens of to 20s of milliseconds. So that was a bit of an issue when you're talking about the consistent performance. Okay, I have to hurry now. So now we got a disk, and then we're talking about the resource. So Apache Mesos is actually resource manager, which is kind of they call the project is kind of punchline is that operating system of the data center. So what they do is that they provide a kind of a homogeneous view of the resources in whole your data center. So as in from application developer point of view or the researcher point of view, you go to this and say that I need 200 CPU, 200 gig of RAM, and then it will tell you go to this machine. So from researcher point of view, they don't bother where the resources are, they just go get it. And it has a support for MPI, Spark, and it has now recently it has added the support for this Docker which is another container for running kind of VM-like frameworks. So we got resource manager, we got the distributed file system to store the data, and now we're talking about processing the data. So one is called Apache Hadoop, which is scalable, fault tolerant, and means it's enough scalable that let's say the Yahoo process almost petabytes of their data using Hadoop. So its scalability is quite insane. What it does actually that you wrote some program or algorithm, it reads the data from the distributed disks, process the algorithms where this data is residing, and then it's kind of sends this result in a reduced phase to a couple of reducers. And then this reducer will sum up the results, what you're doing it, and then write to the disk. And now you come again, then you have to read from the data again to the same, similar or different operation, reduce it, and do it. So it's more disk-based system, which is, it can be good or it can be bad actually. It's good for a reliability point of view and it's bad from the performance point of view. So there is another system which is looked into called Apache Spark. It's similar to Hadoop, but it's a more general purpose, and the main benefit is actually it supports distributed RAM. So for example, in your cluster, each machine has a 96 gig of RAM, but you have 20 of them. So it means that you have 20 into 96 gig RAM of whole cluster, which is usable. So that's beneficial in that part. So what it means in that sense, actually, that take an example of this. You got an input, you perform some operation in Hadoop way, and then you write a result. And if you want to do again, you have to do this, read the data again, and then do this operation and get the result, which becomes slower. Consider a scenario where you have the data from the network, and you want to just, on the same data you're running the operation, give me the top ports of NetFlow. And then you want the top source ports, then you have to do the same operation again, and it takes like 10 minutes or 20 minutes based on your amount of data. And then you want to get the destination ports, it takes the same data again, and it takes similar amount of time again. But for example, in Spark, you read once, and then if you have enough cache, you can cache into the RAM, and then you have running the queries at the RAM speed, which is insane amount of the speed up. So we thought, okay, let's do it. So we run some tests with NetFlow data. So this is a kind of a simple query which we run to get the top ports from the NetFlow data. So this is the old system we had, which is not using this kind of distributed frameworks. So if we run on 120 gig of data to find the top ports in our NetFlow data, it takes a bit more than 3 hours. And if we run the same query on Spark without caching it, it takes 352 seconds, which is approximately 6 minutes, from 3 hours to 6 minutes. And if we cache this whole data into the RAM, then we're talking in less than 30 seconds. So the performance boost from more than 3 hours to less than 30 seconds. So that was quite insane. So based on that, actually what our current plans are is that we're now trying to build a kind of a pipeline so that we actually have a NetFlow data processing coming in all the time. And then another is, because these frameworks are general purpose, they are not specifically tuned to any specific data. So we are now also in a cooperation with proteomics researchers which are trying to analyze the proteins data from the Saint Olav, and also one of the researchers from EBI, European Bioinformatics. So because these researchers have approximately 30 terabytes of data to process, and the way they are using right now, they have around 128 gig of RAM, one box, and 32 CPU, and it's not scalable solution. So they are quite interested into looking into the ways how they can distribute their pipeline and able to kind of scale their performance as well as get the results very quicker. So, this kind of project is actually kind of addressing the big science problem, and it's not just for the researchers. As we see that with the NetFlows and different kind of processing, Endurance has a benefit also of the same framework. And we are talking about the sharing, not just the data but pipeline also. So we have applied. Last year we applied for the Giant 4 project, and currently the status is the blue, which means that they will be considering this again for the year 2 to 4. So if you're Endurance and if you feel that you also have interest in this area, so we can have a kind of a joint collaboration in that part. Because we believe that this is challenge is not only in the Norway, is mostly researchers in different entrants have the similar challenges, so it can be really beneficial to kind of join the efforts. Yeah. Thank you. That was all. So if somebody has a question,
So we have 1 minute for questions, if there's any by now. No, or I guess you'll be around.
Yeah,
the
I
rest
will
of the
be
content,
around.
So,
Yeah.
Thank you. Thank you. So the next speaker is Antti Kainelainen. Yeah. Yeah, close. From CSC, where he's been working since 2008, and I'll just go closer to the mic, I think. He's been working in the group that develops and operates services to utilize cultural data, and he's going to talk about that. So, welcome. We'll give the word to you.
Good afternoon, everybody. So, I'm going to talk about a couple of our services that relate to managing audiovisual cultural data. But I'll start with a few questions. How would you make sure that if you have like a petabyte full of movies, for it to stay unbroken, or to prevent the ones and zeros from changing place, let's say 50 years? How would you make sure that you understand all those metadata that are traveling around? You have millions of files, 5 organizations working together with the system, and physical locations may amount to, like, say, 12. How do you make sure that your grandchildren understand and experience the movies or whatever is in that archive in the same way that it was originally experienced? Well, I actually don't know, but I have a few hunches and related to these services we've been building. I'll come back to this again towards the end. But the big question is digital preservation. That means bits, meaning, and experience, as the questions said. Technically, there's a lot of demands for the infrastructure on performance and scalability. From a developer's point of view and administrator's point of view, there's a lot of demands for continuous development as the environments and systems change. And the last but not the easiest challenge is cooperation. When you have a large amount of organizations with different backgrounds and ways of work, how to get them to work together in a long time frame. I'll start with introducing us and the customer we'll be building these services for, and then show some details about these 2 services, and then come back to the challenges. There's a lot of text here, you don't have to worry about it, but the 2 most important points are that we are owned by the Ministry of Education, and we operate on a non-profit principle. And that gives us a mandate. Actually, it's been given to us by the ministry that CSC offers these centralized services for science and culture. Well, this includes scientific computing, the FUNET network, identity management, data center and capacity services, and what's most related to these 2 services I'm talking about is research data management. Earlier we had a presentation about the Danish approach to research data. Here's the service called TTA, National Research Data Management, is approach to the same problems. The National Digital Library, or KDK as we call it, it's sort of like a Finnish version or Finnish sub-tier of the Europeana service, and related to that is the long-term preservation part of the National Digital Library. Of course, there's a lot of other projects going on in our house, but let's not talk about those. I don't know if you've ever heard of CAVI or the National Audiovisual Institute before. It's a governmental bureau that also works under the Ministry of Education. So we are sort of like siblings working under the same master. Kavi has a lot of responsibilities set by law. They have to archive the audiovisual material and provide means for related research. They also supervise the distribution of movies and audiovisual content, including video games in Finland, like rated R stuff. And they also advance media education in Finland. The most recent form of this organization was named just this year, but the components have been around for over half a century. They have pretty large collections. Well, if you compare these to international collections, they might have bigger, much more movies in the US, for example. But Kavi has the collections of movies, domestic movies, and also of international movies which are distributed or sold or rented in Finland as well. They also have large collections of photographs, posters, manuscripts, and that kind of extra information. A few of the ways how they promote audiovisual culture: they have 2 theaters, they organize festivals, regional series, they have their own library and museum, they publish books, DVDs, CDs, and so forth. And one thing that's been growing in the past, let's say 10 years, is digitization. They have public services regarding to filmographies, which include streaming video, and one of the sort of biggest available to public services is the radio and TV archive, which going to be talk about next. Kavi and CSC started our cooperation officially in 2004 with background analysis, feasibility studies, consulting, and it slowly grew up until the point when we became the technical coordinator of the RTVA project. And a couple of years later, we started building the digital storage archive. And we are aiming for long-term collaboration, because both of these services have included quite big investments for both of us. Our responsibilities in these services have been technical design, tendering, supporting the subcontractors, implementation of our own pieces of those services, integration of those components together, and administration, further development, consulting, and so forth. So, the first service, Radio and TV Archive. The background comes from the law that came into force in 2008, which gave Kavi the possibilities to store digitally the entire program stream of essential domestic channels and weekly samples of smaller channels. And what I mean by entire program stream is it includes commercials, inserts, broadcast errors, and everything that came from your TV. It's not the original material that was given to the TV companies by the producers. It also includes multilingual audio and teletext and all that kind of stuff. At the moment, there are 13 TV channels and 19 radio channels which are stored completely throughout the year, 24/7. And over 100 channels as samples. This is what it looks like from a relatively high level of abstraction. On the right-hand corner, we have the sources of information. Capturing service, which is provided by Digita. They capture the stream as it comes from the air. They transcode it, so it takes a little bit less space on disk. And then, sort of as a complement to that, because without the metadata, we don't know what's inside those files. We get program guides, metadata from music reports, content descriptions, viewer statistics, and everything that describes what this information was, what the videos were, and what they meant to the people at that point in time. And the metadata sources, there's a huge number of those. There's the producers themselves, the channels, a couple of joint organizations, and so forth. First, we get all the data we store in our cellar, in tapes and disks, and then there's a system for metadata management which was developed by another company, VW Group, and Gavi is the organization which uses that system for attaching meaning to those files and correcting the errors and so forth. We also provide video on demand for most of the material we get. And on the left-hand side, there's what the actual end users and the citizens see. They are public access places for searching the metadata, making their own notes, viewing the videos based on the metadata and so forth. And the internet service hasn't been published yet, but it's in the plans. We started doing storage in full in 2009, and it's been available to customers in 2010. And so far we've been storing about program records for about over 6 million programs, and nearly 3 million programs have their video attached. And those 3 million programs amount up to 162.4 years of viewing material if you're interested. And on disk and tapes, it takes about 311 terabytes of space at this point, and it grows up at 59 terabytes per year. So it grows slowly but steadily, and it's pretty big already. The interesting point about these access points is that most of the material has pretty strong IP rights attached to it. So we can't put it on the internet. There are 10 places written in the law that are allowed to show this material to the public. So it's not easy to change the medium of sharing that information. There are pretty extensive security issues related to that, but I won't go into much detail with that. This is what it looks like from a technician's viewpoint. There's a bunch of virtual and physical servers doing different things, from creating thumbnails from the videos and so forth. Then we store all the data on the disks so they can be almost instantly used at the access points. And then we store the data on tapes for long-term storage. This is a virtualized steered storage system, so it can be scaled quite easily. Then there's, of course, the relatively high bandwidth FUNET network for moving the data between the organizations. What's interesting about this in the archival sense is the long term of the preservation. Technically, we have decided to do it by having 2 tape copies and 1 disk copy. Disk copy is, of course, used in day-to-day use, but the reason why we have 2 tape copies is that maybe the other gets broken, or the other tape generation was a faulty one, so the other one is different, so it can last in the test of time a little better. We use checksums as unique identifiers to the assets, and also for verifying the integrity of the data at every step of the process. One big challenge has been the migration of data. Media needs to be refreshed every now and then. The disks burn out. They have their own life cycles. There are generation changes from different types of disk and tape technologies. And the biggest challenges are technically the infrastructure changes. When you can't do the refreshing bit by bit, but you have to do it at one big hoop. For example, we recently did a migration from the old tape archive, and it took months to process all the data, calculate the checksums, and compare the old ones. And building this collaboration with different organizations takes time. There's a customer, of course. They are always important. There's the capturing service provider. There's the company which developed and maintains the metadata management system. There are 10 public access sites. There's another organization, the National Library of Finland, which handles the security at these sites. And then there's a multitude of metadata sources which aren't necessarily interested to work with us because they don't get any money out of it. And what we do is the same things I said earlier: tendering, supporting the piloting phases, acceptance testing, integration, maintenance, administration, data and systems migration, further development, and there's lots of discussions related to legislation and federation and so forth. So let's compare this to the digital storage service. As I said before, Kavi is responsible for preserving Finnish moving picture heritage. Here are some examples what they have been doing recently in the digitization. A lot of the theaters, or almost every theater nowadays in Finland at least, they are digital. You can't show movies that are in old analog films. So if they want to stay current in the heritage area, they have to digitize all the content. But in this service, we are mostly doing just the archiving infrastructure, and the metadata management and public services built by others. You can go check the elonet.fi if you're interested in what they have. What we have archived here is if you have a 90-minute movie, at this moment it takes 29 terabytes to store. There's a master of the original scanned version, 2 copies of it. There's the restored version of it, and 2 copies. And then there's those smaller versions which they can use every day for streaming and so forth. There's all those still images, posters, and so forth, but they don't take that much space. And so far, we have about half a petabyte of movies in 1.06 million files, and we're expecting it to grow up to 700 terabytes by the end of the year. So with these 2 services together, we are hitting the petabyte size by the end of the year. In the future, we are expecting this service to grow faster than the radio and TV archive, with about 350 terabytes per year. Well, I'll skip these technical bits. There's a lot more demand on the speed of the network, because these large files need to be transferred more quickly. There's much more demands for the disks themselves to be able to get that stuff. And there's much more demands on the tape archive itself, because we just can't wait until it's finished, because Kavi needs their own servers to be empty by the next day when they start digitizing the next movie. There's the virtualized networks for handling security, because the original masters, they're not allowed to. There's only a few people even within Kavi to touch those movies. They have their internet there and a demilitarized zone for their customers. There's the public and internal video streaming, and a small special part of the public streaming is for high demand stuff. We are capable of doing 3,000 concurrent streams at 2 megabytes per second each. And the long-term preservation, the needs are pretty much the same as in the other service. It takes months to migrate all this data into a new infrastructure if that comes up, or when that comes up. As I said, for Gavi it's really crucial for them to be able to process that data as quickly as possible. There's a certain process that goes on, and the slowest link in that process is the speed of the whole process. And of course, we are providing these services from shared resources with other customers, so the mileage may vary sometimes. Summarize. Digital preservation, which means constancy of information, intelligibility of information, and the original user experience, but that we leave to the Gavi because they know what's going on in the audiovisual culture. Both of these services were implemented before the Finnish National Digital Library long-term preservation project became more ready. So they're not these services are not yet compliant with METS or OAI, PMH, and other standards. We're expecting petabyte scale storage growth this year, and there's a lot of demands for the performance of the systems. And there's one big challenge is data and process error tracking. So many files with so many organizations and so many ways things can go wrong. Continuous development, that means change management, lifecycle management, and order of magnitude changes in the capacity needs. There were some situations where they suddenly wanted decades of old archive material from the Finnish broadcasting company Yle to be added to RTV, and that's something we are working at the moment. And cooperation, changing partners, changing service providers, even the laws of tendering require that we change these, or at least re-evaluate these service providers every now and then. Customer needs change, and what they want is not necessarily what they need. Third-party integration, we've been looking into making research prototypes into actual production systems in cooperation with the university. And there's the political funding and legal issues. Public sector cooperation, they have their own motivation, and for for-profit organizations to work with us, if we do not pay them, they're not really usually interested in that. And the IP rights is something that limits quite a bit of what we can do with the data. And that's it. Thank you. Questions?
Wow, that was quite impressive amounts of data. So, thank you. Well, we have a little bit of time for questions for all three speakers. And what we talked about, the speakers and I, before the session, that what we could talk about, if you have no questions, is what should the role of the national infrastructure provider be? What should we provide, and what should be left for the local and international level? So if anybody has any comments on that could be the speakers as well. Or if you have any questions. Yeah.
You mentioned that, this is to the national infrastructure, you mentioned that since the report has just come out, you haven't really solved the problem of what's next. How do we put in place governance structures at the national basis? Have you thoughts on that front? What do you think you're going to do next? That was actually mostly to you. But I suppose it could apply to a certain extent to the pilots that are interested in providing services nationally.
So I can only say what would be my guess, but taking your example here, one could ask you, so like this huge amount of storage, like who pays for it and who decides that it's worth it? and how does it? How will you continue to do this the next many years and so on? So, if to answer your question in like what comes next, how do you make this a stable thing and so on? I suppose we need a bunch of pilots like this one to learn from. But admitting that they are only pilots and their justification is pretty random. No offense, but I mean, it could just as well have been any other subject that you decided to invest in and give them a huge amount of storage and so on. Then at some point, you have to have some kind of national grouping, whether it be the board of the national infrastructure provider organization, whether it be the cooperation between the universities. I don't know, countries, they vary, but some kind of structure which takes upon itself to feel some ownership to this and guard the national interest. Probably they will also be the ones coming up with the funding. And that's what I see we're doing now in Denmark. So I'm not pretty optimistic as to we will do something concrete the next few years, but what we will do, we will put this on the agenda and we constantly will address this problem. And at some point, I suppose there will be formed some division of labor, some specialization, some stable funding structures and so on. And 10, 20 years down the road, this will be on track. Maybe like that.
About the value of the content, I guess cultural heritage it's a bit different compared to the other research data, because the organizations are customers, Gavi and others, museums, archives, so forth. They are already established as those who say which kind of content is valuable. Of course, the general public might have their own opinions about that, but still. And they have the funding and they buy it from us, so we don't have to, with this data, we don't have to look for that. But of course, research data, as in the TT and other services we provide, it's a different deal. And that's what you're working with now.
Any comments, further questions? No? Okay. I guess the speakers, Antti and Govinda will be here, I hope, for some time. I know René is almost on his way to the airport, but a few minutes for questions might be, and discussions afterwards might be possible. So this ends the session otherwise, and I just have a few practical remarks, mostly about the gala dinner tonight that will take place in the castle at 7:30. And if you have signed up for the bus, it will leave from the hotels, Scandic and Clarion, at 7:10, at 7:10, and from this place 10 minutes later. And also I should remind you to wear your badge to get in, and I hope to see you there. So, thank you.